Good morning, guys. Today we're going to start a new chapter. This is going to be Notes 2.01, Factoring Out the Greatest Common Factor, Part 1. Okay, and so today our goal is to, by the end of this lesson, to be able to factor out the greatest common factor, or GCF, from an algebraic expression. Okay, so a little bit about the greatest common factor. First thing we should know is that when we use the word factors, we usually think of numbers, right? But factors are the numbers that are multiplied together to get an original number. Okay, so here we're going to say, we're going to put multiplied, that are multiplied together to get an original number. So for example, as an example, right, we would usually say the factors of 6 are 2 and 3. Okay, so what that means, right, is I would multiply, if I multiply 2 times 3, it would give me 6. So factors are numbers that are multiplied together to get a particular number. Okay? But there's a special factor that if it shares 2 or more whole numbers, then those are called common factors. Common factors. For today, we're actually going to be focusing on the greatest common factors. So the greatest of these common factors is called the greatest common factor. So let's move on to what we call the distributive property. So in mathematics, we have this operation or this property called the distributive property. And in order to understand how factoring works, we need to be able to understand the distributive property. Okay, so as an example, let's say I have the following letters. I have A, I have B, and I have C. And so the distributive property says, well, I'm going to make sure I distribute individually, right? I'm going to distribute A with B and A with C. So when I distribute A with B, I get A times B. A times B, and there's multiplication happening here, right? Plus, then I have to make sure I multiply A with the next term, with C. So A times C. So multiplication happening here. So the distributive property, right, it just says if there's a value in front of the parentheses, that value has to be distributed among the values inside the parentheses. Okay? Let's go over to the next page. And so here we have an example of the distributive property with actual, numbers and variables. So we're going to apply the distributive property here and make sure that 3x squared gets multiplied with 4x and with 3. Okay, so when I multiply it, I'm going to end up multiplying 3x squared times 4x plus 3x squared times 3. Okay, so making sure that 3x squared gets multiplied with each term. So over here, we can multiply what's 3 times 4. That's going to give us 12. And then what is x squared times x? X squared times x is x to the third power. Bring down the plus. What's 3 times 3? It's 9. And then bring down the x squared. Okay. And then now the reverse process of the distributive property is factoring. And so this 3x squared that was in the front here, this is going to be our GCF, our greatest common factor. Okay, so our GCF in this case is 3x squared. In other words, what number can I divide both 12 and 9 by? Well, I can divide by 3. I can divide 12 by 3, and I can divide 9 by 3. So the idea here is if I'm looking for the GCF, I'm looking for a number that can divide both the 12 and the 9. And that number is 3. And I'm also looking for how many x's do they have in common. This one has 3 x's, x to the third. This one has 2 x's. So both of them have at least 2 x's in common, or x squared in common. Okay. And so what we want to do is we want to say, okay, if I'm going to factor out this GCF, what's going to be left in the parentheses? Working in the opposite direction. So what we want to do is we want to divide by the GCF. Let me write that again. 3x squared. Divide both of these terms by the GCF, and then whatever we get when we divide, we're going to write them inside the parentheses. So 12 divided by 3 is 4. X to the third divided by x squared. X to the third divided by x squared will leave you with x. And then bring over the plus sign. There's a plus sign here. And then what's 9 divided by 3? It's 3. And then what is x squared divided by x squared? X squared divided by x squared. These will cancel, leaving you with 3. Okay, and notice that I wrote the GCF in front. So whenever you figure out what the GCF is for the problem, we're going to put that in front, and then we have to decide what we're going to put inside the parentheses, depending on what we get when we divide that GCF. Okay, so we're going to keep practicing this idea, but notice that when I distributed, I got 12x cubed plus 9x squared. And then when we factored this answer that we got when we went in the opposite direction, we factored, and what did we get as our answer? The problem that we started with on the left side over here. Okay, so this is just a little example to show you that the distributive property and factoring are opposite operations. Okay, so let's look at this first example. This first example says, factor the following algebraic expressions, show all your work. Okay, so we're going to factor, but we need to find the GCF. We need to find the GCF, the greatest common factor. So we're only working with these two terms, right? 24x squared and negative 3. Do they have any x's in common? No, right? This 3 doesn't have any x's. What about the numbers? 24 and 3. Is there a common factor there? You know, what two numbers multiply to give me 24 and give me 3 that have a common factor? Well, can I divide 24 by 3? Yes. Can I divide 3 by 3? Yes. So my GCF here is 3. And so we're going to write the 3 and open a new set of parentheses. And we're going to take the GCF and divide both of these expressions by the GCF. Okay, so we're going to divide and then we're going to write our answers in the parentheses. So what's 24 divided by 3? It's 8. Bring down the x squared, bring down the minus, and then what is 3 divided by 3? 1. So this is my answer for the first example. And notice, right, if I multiply the 3 back in, do I get my original answer? And if the answer is yes, then we did the correct factoring. So again, to check my answer, if I multiply 3 back out, if I distribute 3 back out, it should give me my original answer. Actually, let's check it, right? Let's do a quick check. So what I was saying is if I multiply 3 back out, what's 3 times 8? It's 24. Bring down the x squared. What's 3 times negative 1? Negative 3. And so did I get the original answer back, or the original problem back? Yes. So then the factoring that I did is correct. Okay. Let's look at the next example. Okay. So again, we're looking for the GCF. If the problem says factor, if the instructions say to factor, then the first thing we want to identify is the GCF. And so if I look at the numbers 7 and 56, do I have a common factor? Right? Can I divide 56 by 7? Yes. Can I divide 7 by 7? Yes. So I would say, both of these numbers are divisible by 7. So that's one of my common factors, or my greatest common factor. Do both of these terms have an x? Do both of those terms have an x? You would say no, right? So the greatest common factor is 7. So remember, we're going to divide both of these by 7. And then we're going to write, the GCF in front of a parentheses, and then we're going to write whatever we get when we divide, we're going to write it out in the parentheses. Okay? So actually, let me put a little bit more space here. Okay, so -7 divided by 7 is -1. Bring down the x. And plus, bring down the plus sign. What's 56 divided by 7? It's 8. And so I'm just going to rewrite it a little bit. So there we go. I factored. And so again, in factoring, we're taking out what the two terms have in common. What is their greatest common factor? All right, let's go to example 3. And let's find the GCF. Okay. So if I look at these 3 terms, right, 1, 2, 3, do they have any x's in common? You know, the first 2 have an x, but the last one doesn't have an x. So they don't have any variables or letters in common. Do they have any numbers in common? You know, is there a number that you can divide 8 and can also divide 3? No, right? But what they do have in common is that they can all be divided by a -1. And sometimes we do this, we factor out, or we think of -1. Let me rewrite it because I feel like it's crooked. But sometimes we factor out a -1 so that the first term can be positive, especially this x squared. Okay, so we're going to do what we did in the previous example, you know, and so I'm going to put the GCF in front of the parentheses, and then I'm going to divide every term by this GCF. And so what is -x squared divided by -1? That gives me a positive x squared. -3 divided by -1 gives me a positive 3x. And then positive 8 divided by -1 is -8. So this is my factoring. Okay, let's go on to example 4. Right. Example 4 says, factoring out the greatest common factor does not just involve numbers, but can also involve variables. Okay, so the greatest common factor in this example, now it says it can involve variables, not just numbers. Okay, here it doesn't, even just looking at the numbers in front of the x's, there's nothing, you know, unique about it. It's 1 and -1. But if I just look at these two terms here, they both have something in common. They both have an x, right? So my GCF for example 4 will be an x. So we're going to write the GCF this GCF, we're going to put it in the front of the parentheses, and then we're going to divide by the GCF. Okay, so the first thing is, what's x squared divided by x? It's x squared divided by x gives me an x. Bring down the minus, and then what's x divided by x? Something divided by itself is 1. So this is my factoring. Let me erase this arrow here. All right. Let's go on to the next one. Or actually the last one. Example 5. Let's try and identify what the GCF would be in this case. Okay, now let's look at the numbers. And again, it's up to you. Right? We can look at all the x's first, or we can look at the numbers. But what kind of stands out to me is that the 3, the 5, and the 6 do not have a common factor. Right? There's nothing that you can divide 3 by that can also divide 5. And there's nothing that you can divide 5 by that you can divide into 6. So as far as the numbers go, they don't have anything in common. Now let's look at the variables. We have 1x, 2x's, and 3x's. So we can say that they all have at least 1x in common. So that's my GCF. I'm going to divide these 3 by that GCF. And so I'm going to set up my parentheses and put the GCF in the front and divide. So I have 3x's divided by 1x. Or let me bring down the 3 first. And then let's look at the x to the third and x. What's x to the third divided by x? And what we want to think of when we divide x's, actually, is if I have x to the third divided by x, that's the same thing as having x times x times x divided, sorry, it's crooked, divided by x. And so we can cancel these two out, which would leave us with x times x, which is x squared. So we're going to get x squared. So I'm going to erase this. This is kind of a side note there. The next thing, bring down the plus 5. Let me move this parentheses because it looks like we're going to need space. So I'm going to move it more out there. Okay, what's x squared divided by x? It's x. And then bring down the minus 6. And what's x divided by x? 1, right? 6 times 1 is 6. So my answer is the following. All right, so this brings us to the end of the notes on greatest common factor. Thank you for joining me in this note session, and I'll see you next time in class, and I'll go over any questions you may have had in the video, and we'll work on the activity. Have a great day, guys.